Okay, today we will study some laws that allow us to do some algebra and find the limit. Okay, very good. And here are the laws. Remember, suppose C is a constant and the limit exists. Then it means that these two guys exist. Otherwise, we cannot say anything about this. Suppose these two exist, then we have some laws here. The limit of sum of two functions is equal to the limit, the sum of two limits. Okay. Second one, the limit of a difference will be the difference of limit. Or in the next slides, show you the verbalities and verbal of this and the notation. The third law, constant multiple law. The limit of a constant multiplied a function will be that constant multiply the limit of the function. And the next one, the product. The limit of a product will be the product of limits. Okay. The last one, the limit of a quotient will be the quotient of limits. And the last one is very tricky. Which condition do we need here? Yes. So whenever we talk about quotient, the denominator should be defined. Otherwise, it's no longer correct. Okay. So the condition is that the limit, it means the denominator is not zero. Very good. That's it. Now, let us play with some examples. The first one, suppose we're given the graph here. Okay. This is the graph. The red lines here is the graph of f. The blue lines here is the graph of g. Do you all see it? From the back, can you see it clearly? Good. Then, the first question, what is the limit of this sum? Now, take a look at the laws here. Write your own answer. And we'll double check it in a few seconds, okay? Just try it yourself to prove it using the law below previously. Okay, write it down. Try to apply the law and indicate which law you use. Okay? You ready? Okay, very good. Now, the first one, there's some hints. First, this is the limit of a sum, right? There's a sum here. So the first law say that the limit of a sum will be the sum of the limit. So what should we write here? Very good. 5g of x. But x goes from x goes to -2, right? The same thing. Okay. By the first law. Then what should we do? Yeah, it is a constant multiplied a function g, right? So we use the third law. So it would be this guy. Let us rewrite it. Plus 5 times the limit of g of x as x approaches -2. Is that clear? Okay. Get it? Very good. Thank you. And then here, look at this. What is the limit as x approaches -2? Very good. -2 is right here, the limit. We can see that from this value, it is 1, right? Then this guy, allow me to write it this way, 1, right? And the number 5, we just write it again. What is the limit of g as x approaches -2? -1, very good. So it will be, remember, it is 1 plus 5 times -1. And the final answer will be, yes, -4. Okay, very good. So are you comfortable with this proof? Good. Then the next one. Oh, the next one is tricky. So we need to compute the limit of a product. So look at this. Which rules should we use? 4, right? It is a product, so we use the product law. So, but before doing that, we see that we're looking for the limit at 1, right here. Double check it. At 1, it means that at this line, when x is equal to 1 along this line. So look at this. In the graph, what is the limit of f of x? F of 1, yes, 2, very good. What is the limit of g? Good, does not exist. Because why? Yeah, the left-hand limit approach, what is it? -2. How about the right-hand limit of g? -1, right? So we see that the limit of f of x is 2, but the limit of g does not exist here. And the right-hand limit of g, according to this graph, it will be -1, as you say. And what is it? -1? From the left side of 1? -2, right? So the limit of g does not exist. Therefore, we cannot compute the limit of the product. It means this guy does not exist as well, right? Since limit when x approaches 1 of g of x does not exist. Okay? But we can compute the left-hand limit of this product. So the left-hand limit of this product, since the left-hand limit of these guys exist, then we can compute it. So the first law, what is it here? the product law, the law 4, right? Then we have this equality. So what is the value of this guy? 2, very good. And what is the left-hand limit of G? Yes, very good. 2 times -2. When you write your answer, remember, this is a negative number. You should have a parenthesis here. Otherwise, you will confuse the reader. If you write it this way, this is may confuse and make mistake. Do not do this. Okay? I saw some student in previous semester did that, and it's not true. So we should do this here, and the final result will be good job. How about the right-hand limit of these two guys? The same things, right? The right-hand limit of f of x will be 2, very good. And the right-hand limit of g, -1, good job. Oh. Then finally it will be great. And we see that the left-hand limit of this product different from the right-hand limit of this product. So this is another way to say that it does not exist. Okay. Is it clear? Correct. Doesn't exist. Okay. Great. So now the next one. So we need to compute the limit of this quotient at 2. Where is 2? 2 is right here, right? Then look at this. What is the limit of f of x at 2 when x approaches 2? Yeah, somehow around here. Let's guess is when x approaches 2 will be around, it's not very clear, but let us say 1.5, okay? Estimated. How about the limit of g? Oh, nice. Very good. It will be 0. Can we apply the quotient rule here? No, so be careful. We cannot use the quotient rules here. So cannot use the quotient rule. Therefore, the limit of this guy does not exist. Okay. Undefined, yes. Right? Yes, no solution or undefined. Good. Okay. Very good. You're doing well. Everything is clear now, right? Good. And here are some other rules. So the first one, you can apply the quotient rule multiple times, right? You write it down, the limit of f of x times f of x times f of x n times. And then you use the product rule n times. You get this result. Okay? And again, limit of c, a constant, is equal to that constant. Why? Can you show it on the graph? Okay, we're trying to do this, right? Trying to understand this, x and y. They say that the limit of c when x approaches a is itself. C is a given constant. So in this case, what does it mean? It means the function f of x we're considering here is c. in this case, right? And what is the graph of this function? Sometimes we also write it y is equal to c. In this case, y, or sometimes we say y is f of x. They're the same things. So if this is c, how does the graph of the function f of x is equal to c look like? Yes, the horizontal line here. This is the line y is equal to c, right? This is the graph of this constant function. See it? Great. Now we consider if x approaches for any value of x, we have the same result. If this is 1, in y will be c. If it is 2, it's also give us c here. So in general, if it is a, then the limit of this is always c. That is how you can see it in the Cartesian coordinate. So just for now, just accept this. And there are some law. Okay. Limit of x when x approaches a is a. So let us try to show it in the Cartesian coordinate. So limit of x when x approaches a is equal to a. This implies that the function of f of x will be, what is it? No. It indicates that the function we are considering here in this case is fx is equal to x. That is what we're talking about. Okay? And the function f of x is equal to x when you plot it. If x is equal to 1, what is f of x? 1 as well. Very good. It means that, okay, how about at x is equal to 2? Yes, 2, right? Y is also 2. And here is the graph of the function f of x is equal to x. Or sometimes you write it, y is equal to x here. Okay? We see that if x approaches a given number, let's say a here, right? According to the graph here, if x come closer to a, then f of x come closer to f of a right here at this point. Makes sense, right? There are some other laws. Okay. X to the n. So it means we can directly substitute this, right? And here, the radical sign here is a bit tricky. If n should be positive, remember. And the condition, the radical condition, if n is even, from the definition of the radical function, if n is positive and even, then a should be strict larger or equal to 0. That is the condition of the function. So now, when we consider the limit, we don't care about that value. So the condition of the radical sign here implies that a should be positive, larger or equal to 0. But however, we are considering the limit near 0. So since it is a limit, so near the a, we should pick a should be strictly positive, just condition, remember it. And here, the root laws, the limit of a root of a function, and n is a positive number, again, will be the root and root of that limit. Okay? For these laws, what you need to do is to memorize this and apply. Okay, that's it. Now we don't have to guess. We don't have to try different values. We can use this law to prove. Okay, just memorize it and try to do it. Now, and another thing, here, direct substitution. If we're given a function f of x, and remember, continuous, it means that a function is continuous. It means that we can draw a graph of that function without taking our hand up. So for example, we're given a graph like this. This is x, and this is y. And we draw a graph like this. So it is a continuous function. If we have to take the pen up and draw it, it is discontinuous right here, right? Just a new concept. If a function is continuous, then we can directly substitute the value. And again, if f of x is equal to g of x when x different from a, and the limit of these two functions are the same. Yeah, just from this, and we have a constant lemma here, provided the limit exists. And again, we meet this guy against the limit, right-hand limit and left-hand limit are the same, then the limit exists. Now, let us quickly do this example. Limit when x approaches 5 of 2x squared minus 3x plus 4. What is it? Try to do it yourself, and we'll see. Do you get an answer yet? Okay, let's do it together. First, this is the limit of difference and sum at the same time, right? So, which law should we use? The summation and difference rule. Okay? Then it means that it is the limit of the first guy, 2x squared, when x approaches 5. What is next? Very good. Limit of plus okay. So we use the law 1 and 2. And then what should we do next? It is a constant, right? Yes, we can pull it out. It would be 2 times limit when x approaches 5, x squared, minus limit when x approaches 5, number 3 here, x, plus limit of a constant would be, what is it? Yes, the constant. Very good. Okay, be careful. So here, the polynomial x to the n is continuous. All polynomials are continuous. So we can use direct substitution here So what does it mean? It means this guy, we can substitute x by 5 from, where is it? Oh yeah, here. Direct substitution, okay? It means that this will be, very good, 5 times, 3 times, sorry. Very good. And the final result will be 39, okay? Yes, for you, after doing this, we see that the polynomial here is continuous. We can simply apply the direct substitution directly. But yeah, I just want to show you how to use some laws step by step. Okay. Thank you and have a good one, everyone. I'll see you tomorrow.